values get inserted in level order traversing.
Oh, that's okay, but that's not required. Means that's all words means level order traversing, level word insertion. That's okay. That's not actually the complete answer. Anyway, I'm writing whatever is the point because
Ma'am,
even
element with greatest value will be in the root node means.
yes, you forgot means you remember you can remember few of the terms but not all.
Yes.
Okay, only one relevant information that I understand, that is complete binarity. Yes, level wise we will do the insertion. That is common for each tree, each of the tree, be it binary, be it non-binary. If I need to make a complete or full binary tree, then I need to insert the element in level wise manner. Okay, fine. So let us start. Okay, this is your main 2-point agenda. That first of all, it has to be complete binary tree. Now, based on the number of element or the data, it may be full also, that's okay. But another important thing is parent is greater than equals to both child, or parent should be less than equals to both child. So if parent is greater than equals to both child for the entire tree, then it is called max heap. And if parent is less than equals to both child, then it's min heap. Now, whenever we form the max heap, then root will be with the largest number. And whenever you construct the min heap, root will be the minimum number. Okay. Where we apply this heap concept, that during runtime in your memory, there is an area for runtime, all kind of calculation, assignment, temporal scheduling and everything. They do this in a memory heap area. So what it do? It maintain everything, that which is coming first, which is coming after that, the sequence, anything related to the priority or anything, that all maintained by the heap. Okay. It's not only about that what we understand as a simple tree making, which is called heapify. Means from a given data set, when you make a heap tree, that's called heapify. That's called heapify. Okay. So whenever you are making that, that's okay. But where the application, say we have studied the priority queue and all, but how those can be checked, all the priority based things or anything, those are easily maintained with a heap. Those can be easily maintained with a heap. That is the application of the heap. Okay. And another thing is the time complexity. If I need to do the heap short, we'll discuss step by step the making of heap tree and heap shot. The time complexity of heap shot, that is also very good. That is n log n. Okay. So if I consider the max heap, say 17, and it will be this kind of thing to be maintained in entire 3, then it is max heap. And if the reverse thing is there, then it is your mean heap. Fine. Now, how we are supposed to do the entire thing? Creation or the insertion. In which direction? Now, level wise, left to right. That is your insertion. So if the elements are say these are your elements, okay, and you are trying to do the mean heap tree. So what you are supposed to do, first you take 8. Once 8 is taken, fine. Next you will take, whenever I take 7, but 7 is less than 8, so swap them and it will be 7, 8. Okay. Next element 11. Fine. 11 is less than 7, so no issue. Next 9. 8 is less than 9, no issue. Next insert 5, and you will find that you have to swap. So after swapping, this will become 7, 11, 8, sorry. 5, 8, 9. Okay. Next is 4. So 4 will be inserted here. Next is 7. Again, acha, should I insert the 7 or not? Should I insert the 7 or not? Should I insert the 7 or should I skip the 7? Tell me
Skip
whatever
the
you.
7.
Hmm?
Skip the 7 and move to 3.
No, ma'am, it will be inserted. I think so.
Okay. So both of you give your own justification. Whoever is telling that to keep the 7, tell your justification, and whoever is telling as keep the 7, tell your justification.
No, ma'am, no, ma'am. The 7 will be inserted. In case of heap, you have to insert it.
Yes. The reason is it's not only greater than or less than, there is one equal symbol is there. And that makes difference with your BST. Okay. That makes difference with your BST. So 7 will be inserted here. Oh, I have done another mistake. Before I insert the 7, I should check that the moment you have inserted the 4 is less than 11. So it has to be changed. So 7, 4, 11, then 5, 9, 8. Oh, till now it's not done because after this is also a change. Talking, but I didn't achieve. So once you have done this side, this particular change and this particular change, so you have inserted 4 after the 5. So first thing that you need to do, that is 5 is even less than the 7. So you should change it first before you insert any other value, because you are not supposed to insert any value till it's in a balanced state, or you may say till it is in a proper heap format. Now you insert 4, so it will be changed from here, and gradually the change will reflect to here also. I'm doing it at a single step. So 4, 5, 11, 7, 9, 8. Then this side another 7, and this side 3. And again you need to change these two. So if I change the position of these two, first it will become 3, it will become 9. Then you need to change this to the 7 and 3. Still it's not okay. You need to change with this 4. So see, this particular tree is having the smallest number in the root. Second smallest numbers are in the next level. Third are in the next, and so and so and so. Now, this tree is a heap tree, mean heap tree, where every parent is less than their child. Okay. So the tree heap is done properly. It's being prepared properly. Okay. So how, if I need to do the sorting of these numbers using this heap tree, how I can do? For that, what you need to do, you need to replace, you need to delete the root and replace this position with the last element. That may be the rightmost element, or you may just consider that is the last element in the tree. So once you can replace it, then again you need to do the heapification. So if I need to do the deletions, I need to go it in this way. The tree is 3, 4, 5, 11, 7. কে ছিল এদিকে?
8.
8, yes. 8, 7, 9. Okay. So this is, say, your tree. Now, if you need to implement the heap sort, what you need to do first, you just remove it. First, you remove the root. So it will come, say, not here. And then it will be replaced by 9. So as soon as you write here 9, what will happen? 9 is more than 4 and 5. So you should exchange it either with 4 or with 5. That is completely your choice. Say you are changing it with 4. Say. Well, it's not still okay. Again, change it. So if you change it, it will become 4, 5, 7, 9, 8, 11, 7. Okay. Now you delete it with 4, means the delete the root, and it has to be replaced by the last node. Now, which one is the last node? 7 is the last node. Now, someone if not understanding, for them, I'm just telling this, how I'm telling that this is the last node or this is the last node. If I check the node, traverse the node level wise, the node which comes at the end, how I am traversing 4, 7, 5, 8, 9, 11, the node which comes at the end, that you may say that that is your last number. Now, you take 7 here, but again, this side it's okay, but this side you need to make a change. Change it, and this will become 5, 7, 7, 11, 8, 9 ছিল এখানে, হ্যাঁ এসছে তো, হ্যাঁ ঠিক 9. Okay. So now it's in stable state, so you can change again. You can change it to the 5. Okay. So the moment you can change it to the 5, it has to be replaced by this 11. So the 11 will go here. Fine. Again, the 11 is bigger. We are supposed to again do the swapping. So you can again swap this with any of the 7 of your choice. And this will become 7, 7, 8, 9, and this side, this is 11. Okay, fine. Now, again, you delete the root 7. Which number to be used to replace the 7? The 9. So if I again keep the 9, 9 again has to be swapped with this 7. So this will be 7, 9, 11, 8. Fine. Again, you have to do swapping of this. So making 8 and make this 9. Fine. So again, you replace this 7 to be replaced by 9. 9 will be here. Again, you have to do the swapping of this to this. So it will become 8, 9, 11. And then you replace 8. Replace the 8 with 11. So it will become 11 and 9. And then again you do the swapping. So it will become 9, 11. Then you delete 9. Then only 11 will be there. So see, if my input is mean heap, if I have prepared mean heap, then if I do the heap sort, which involves deletion of the root and replacing it with the last number, then the final result will be your ascending order list. Similarly, if you do the max heap for your sorting, you will get the descending order list. Okay. Now, what kind of questions you can expect? One thing, if priority-based things you need to deal with, you may go for this one. Or if you need to if you need to do any kind of sorting, that may be priority or anything of huge numbers where chances of repeated number may exist, then also you can use the heap sort. And no other special features are there. It's only this much. Okay. And depending upon the situation, the max heap or min heaps are being done. So this is the thing. So if you have any query, you may ask, or I can. And moreover, those who are not so confident, then they may practice it as max heap also. Okay. I have shown you the min heap, but you can get it, you can practice it as a max heap also. Okay. So if you have any question, please put forward. So now I will discuss about the Huffman tree and Huffman coding. But before I go for this Huffman tree and Huffman coding topic, I should tell you one thing, that why it is there. See, whenever you need to store something, store a file or anything, it may be comprises of many important characters, and many characters may be there which are not so important. Okay. But whenever you need to store it as a whole, it will be one entire file. So to use the memory more efficiently, there are different compression technique which involves a method where the least important part are assigned lesser space, and more important parts are getting more space. How things are being done? Internally, whenever you are trying to store something, what we do, or what the system will do. Now, as I have written here, this Huffman tree, say for each of the character, there is some code and things are being stored as it is. Normally, we find 8-bit code for each. So whenever I'm trying to store this, they will be stored those many positions, 8 bit for one character. So that would be whatever the total length of your data will be multiplied by the 8. But if I want to compress it, what I need to do? I have to reduce the storage space. How I can reduce the storage space? Now I can reduce the storage space by reducing that code length. Now, if I use fixed length code length, then also the letters or the characters which are repeated again and again, say F, here it is used 2 times, say E, it's used 2 times. So they will take that much double space as compared to other letters. Again, people have thought how to reduce this use or how to reduce this space requirement. So they have formed, or the mathematician, or you may say scientist, whatever, they have proposed this kind of tree where tree will be formed based on the priorities or occurrences of the characters. And after forming the tree, he has given us one method to find the code length for each of the character in such a way that the length of the code may not be equal for all the characters. And as a result, you may get the percentage of memory that is lesser, means percentage of memory that will be required, that will be lesser as compared to any kind of fixed length coding mechanism. Okay. So what can be, if I need to form the Huffman code for each of the character, what is the requirement? Your requirement will be, ideally, if I say that you have to solve that, it may be one entire paragraph given, and you are being asked that you need to find the code of each character. But that is not possible all the time. Means that is not possible in the sense, in that case you need to, either you need to count it by your own calculation, or you need to use one text file to store the data, and then you need to check each of the character and make a count that how each of the characters are related. How each of the characters are related. Okay. So this is the way you have to do it. This is the way you have to do it. Either you will be given the entire sentence or paragraph, you need to check what is the number of occurrences of each character, or list of characters and their priorities or the occurrences will be given to you. Once it is given, then you need to perform the formation of the Huffman tree and the coding. So say your elements are A, say these are the characters, say, just for example. And the occurrences of these characters are 20. These are the occurrences. What is the first step? If I need to form for a given tree or given data set the Huffman coding, what is the first step? First step is sort them as per their priority or the number of occurrences. Okay, if I sort them as per the number of occurrences, then this B and H, they are the minimum. So either in step by step, you may take two minimum, or if you want, you may start with sorting them. Okay. So if I'm not sorting them, then I can directly write also in this way, B5, this side, H5. And once this is done, you have to merge it as 10. Okay. So once you have taken this, you will just cross, and here 10 will be written only. So now out of this 20, 17, 6, 8, 15, 10, which two are minimum? Not these two are minimum. So take them. And will be this, right, 14 here, and this will be not taken. Next, which two are minimum? Next, this 10 and 14 is minimum. So merge them, we will get 24, and it will be here. Then 15 and 17. So you have taken 15 and 17 and take 32 here. So out of them, 24 and 20 is lesser. So 24 and 20, so it will be 44. It will be a 20. So 24 is used, 20 is used, and last is this 32. So merge them. So if I didn't have done any mistake, which part to be repeated? Okay, I'm repeating the entire thing. Someone has requested me to repeat the thing. See, whenever you get the inputs, maybe it is as a sentence or paragraph, or maybe as a this random input, the letters or the characters and their occurrences or the priority. So here 25, 17, 6, 8, 5, 15. These were the priorities or the occurrences of this character. And A, B, E, T, S, H, U is the character, specific character. So job is what? At each step you have to merge. At each step you have to merge. What to? You have to select two child node. you will select minimum at each phase. So at the beginning, the very minimum was B and H, as both of them is having the weight 5. So you take them, and if you merge them, you will get one node with load 10. Okay. Next, if you need to, so once you have taken those two nodes, those suppose not to be taken anymore. So you take the 10 that side and cancel out these two entries from here. Fine. So the entire wait list is updated with 20, 17, 6, 8, 15, and 10. So once you do that, then the next thing is that you will find that 6 and 8 are with the minimum weight. So merge them. Once you merge, you will get 14. So 14 is again new weight, and T and S will be removed from the list. Then you can find that this 10 and 14 is the minimum number. So merge them. Then you reach the next level and write the 24 there by cancelling out this. Then you got next minimum number as 15 and 17. So merge them. Then you got 32 and 20, 32 and sorry. Then you got 20 and 24 as minimum. Merge them. And at the end, this side you have 44 and that side you have 32. So you have to merge them. You merge and the complete tree is done. So the person who has asked me to repeat, I have repeated the entire procedure. So is it clear to you? Okay, fine. He has replied, he or she. Now, how I can, this is the tree formation, fine. But how I can find the code? For that, we do what? For that, we will write in this way. For every parent node, in the left child part, there will be 0, right child part will be 1. Left child 0, right part 0, right part 1, right 1. Left 0, right 1. Okay. And now, for each of the character, from the root to that particular node, whatever the path it can get, that will be considered as its code. So for A, it is 0, 1. For B, 0, 0, 0, 0, all 4, 0. For C, is there C? Sorry, no C is there. For E, say E. Where is E? Where is E? E is here. What is the code? 1, 1. For H, what is the code? 0, 0, 0, 1. For T, 0, 0, 1, 0. For S, 0, 0, 1, 1. For U, 1, 1, 0. No, where 1, 1, 0? It's only 1, 0. Only 1, 0. Okay. So you can see here that the minimum length of the A, E, and U, that becomes 2. And for others, the length of the code is 4 bit. Yeah. And if you can see the previous thing, A, E, and U, they are having highest occurrence. They are having more occurrences as compared to B, T, S, H. So now, if I try to store the data with this Huffman code, these are the Huffman code. So if I try to store the data, how much space will be required? Now, how many A is there? Na 20. How much bits are required? Na 20 into 2. 40 bits are required to store for A. If I go for B, B is 5. Okay, 5 into 4. This way you can do. E is 17. So 17, what is the code size? Na 2. So this way you can calculate. And if you calculate this and if you compare this with the total number of characters, that is 20 plus 5 plus 17 plus 6 plus 8 plus 5 plus 15 multiplied by 8, then you will get the space requirement if Huffman coding is not applied. And by this calculation, you will get the space that Huffman tree requires. Okay. So this way you can get how or how much space can be saved. Okay. So what kind of question you can get from here? First of all, the use and all, that is for data compression. Next is part of the tree can be given. You may be asked that if I insert this, or can I insert this, what will be the next code? Or maybe the 0, 1 is also being placed over the tree. You may be asked for a particular code. Means you need to calculate it. Means half done things may be given to you. You need to complete and find the answer. Okay. And another thing is, that is very interesting, that for us later, my code for B is 0000 and for H is 0001. Not necessarily your code will be exactly same. Yes, but what can be same at least? The length of the code, that is, this is 4-bit for my problem solving approach, and that may be same for you also. That same for you also, that can be also this kind of thing, that that is also 4-bit, that is expected. But the codes may not be unique, because which node I am taking in the left side and which node I am taking in the right side, there is no specific rule. So as no directional rule exists, so the code may differ, but the code length generally same. Okay. So if you have any question regarding Huffman tree or Huffman coding, you may write in the chat. I may discuss. Yes, you may write. Okay, can anybody tell me something about the B tree? What is B tree, or what is the speciality of B tree? Can anybody tell me? What is the speciality of B tree?
Ma'am, it contains sorted data.
Where? Is the speciality of B tree, that it contains sorted data? What is the speciality of B tree? Means till now, whatever the tree I have discussed in last 2-3 days, what is the difference? You have studied all these earlier. So what is the difference? What is the difference? Try to remember, or you have studied these earlier. So what is the application? You have studied even one application also. You have studied the application of B tree application, one of the application.
Ma'am, store data on a disk.
Acha, okay. Yes, that can be. That can be considered, that can be taken. Okay. That is okay. Fine. What is the difference of normal tree, and what is the difference of the trees that I have already discussed with B tree?
Ma'am, it performs the searching, insertion, deletion in logarithmic time.
That's okay. That is not actually difference. That is not actually very.
Like in B tree, all leaf nodes will be at same level.
So that is also okay. Where is the difference? Even in full tree, all leaves are in the same level. What is the speciality of the B tree? And what is the difference of B tree and binary tree?
Ma'am, in B tree, it has a particular order and key. Like
Order and key. What is order and what is key? What do you understand by the order of the tree? B tree. What can be considered as a ordered of a B tree? What is called order of a B tree? Or what is the difference between order, B binary tree and the B tree? Okay, first of all, I think either you didn't have studied or you may have forgotten. B tree is not at all a binary tree. It's an M array tree, or you may think that it is an M way tree. Okay. So M way tree or M array tree means what? Binary means every node can have maximum 2 children. Here, M means every node can have maximum M number of children. And is there any, that is maximum. Is there any minimum? Yes. M by 2 is the minimum number of children. Okay. All leaf node must be in the same level. That is correct. Another thing is B tree is capable of in such a way that every node can contain more than one value. Every node can contain more than one value. Okay. So that's why the tree becomes more bush kind of nature, because every node can have m number of children. Generally, m is greater than equals to 2. So as it is greater than equals to 2, so what will happen? Now, many number of keys can be placed in a short length. You no need to go deeper to insert each of the node. And so it can store more data also. Okay. So now we will take some value and we'll start. So for the B tree, to form a B tree or to work with B tree, we need to know the elements which are to be inserted and the order of the B tree. What I need to know, the elements and the order. Okay. This order or the M is related to in this way, that M way tree or the order 4. Order 4 means this node can have maximum 4 children, and this node can have maximum 4 minus 1, 3 child node. Okay. This is the very preliminary thing that we need to know. And where is the difference? Now, in case of binary tree, binary means 2, so m equals to 2 only. But in case of B tree, it can be any integer value. The length of the tree is not much more, rather it's spreaded more. So that is the features of your this tree. So let me take one example. Say B tree of order 5, B tree of order 5, that is m equals to 5, and you have the elements are say 20, 30, 35, 85, 10, 55, 60, and 25. Now, how we can proceed with this? Now, we can proceed in this way. We will take the element and we'll keep it in a node. Whenever we are keeping it in a node, we will try to keep it in a sorted manner. The moment the particular node is full, that is the moment you will get 5 elements in a node, it has to be splitted. If the order is 5, then number of values that is allowed within the node, that is 4. If order is 4, then number of values that is allowed within a node, that is 3. If it exceeds that level, that moment you need to split it. Okay. So here you take 20, okay, 30, okay, 35, that is also okay. Till now, whatever the numbers I am taking, they are in a normal sorted order. Next, you take 85, that is also okay. Now, the moment you take 10, it has to given here. And it becomes 1, 2, 3, 4, 5. So you have to break it. This is your one node. Yes, you know, in the step by step means first you may take 20, then 20, comma 30, this way. But as we are not doing all these things for some semester exam, so what exactly means, what kind of question you may be asked, that you may be asked obviously what is the utility and all, that is for your interview purpose. But if you need to solve the problem, again value or partially done tree will be given to you. You need to perform certain insertion or deletions or anything. So here the moment it will become 5, as the order is 5, you have to break it. So what you need to do now, whenever you need to break it, how you will break? You cannot do it randomly. You need to take either the middle element, or if even number of elements are there, say the order is 6, then you are going for splitting when the number of elements will be 6. So in that case, any of the middle element you can take. No further calculation is required, that calculate the median and they know, no such thing. Take 30, there will be 10, 20, and this side will be 35, 85. Okay. Next, the value is 55. Now, where to insert? Again, the way we deal with this, it's almost similar, a little bit similarity we'll get with the binary search tree, that is BST. 55, where to insert? You are supposed to insert here. So write it 30, 35, 55, 85. And this side 10 and 20. So you can see that insertion will also take place from the leaf level only. Not only the leaf level, leaf node will be in the same level, but also the insertion will also take place from the leaf node only. Next node is 60. Insert here 60. So it will be 30, this side 35, 55, 85, sorry. This will be 60, then 85. And this side, after that, you will get 25. So 10, 20, 25. Okay. So now this is your structure that you can form with these given numbers. Now, say I am telling you that insert, this is the tree as of now. I'm telling you that insert 28. Okay. So where you will insert? Definitely in this. So if you insert here 28, 35, 55, 60, 85, again this will become 5. So then what you need to do? You need to take the middle element for splitting out this node. How or what is to be done? This 55 will go to the up level. So this will be, if I say that we in this tree, you again insert some more node, then the root will change to this 30, 55. Fine. Then this side 10, 20, 25. This position is for the middle, that is 28, 35. This position will go for 60 and 85. Fine. Similarly, if I now ask that insert 5, if you insert 5, 5 will be here. If I ask, say that insert 27, so then it will become 5, 10, 20, 25, 27. Again, this will become of 5 nodes. So this will go up, and it will look like how? It will look like 20, 30, 55. See what happened. So what actually we are doing, every time number is supposed to be inserted from this bottommost level, and whenever it becomes full, means more than full, it has to be splitted. So every time that value which you are taking for the splitting, that will go in the upper level. Okay. So this will become 5, 10. This will be 25, 27. This will be 28, 35. This will be 60, 80. So this way it will continue. Even in some phase, if continuously you are populating the leaf level, and for that this initial root level also populated, then also what you need to do, then also when it will be of, like, it will also become a tree of a node of 5 values, then you need to again split this particular node in 2 parts, and the middle, say here some values continuously coming, say 60 also coming, because of here addition of more and more number, then again whatever the middle, that will go up, another level will generate, and then the rest of the things will be managed. Okay. Anytime if you want to check that whether things are correct or not, how you can check that? You start from here 5, 10. Then you go for this, then you come, then you go, then you come. And if you find that, okay, this order is a kind of shorted, that means whatever the operations you are doing, that is correct. Okay. So anyone having any query regarding the B tree formation? Yes, we have the deletion process, but before that, I'd like to ask you that if you have any query regarding the deletion process. Any query regarding the B tree creation, or do one thing. Do one thing. You will tell me, say, order of the tree. Take the order as 4, and keys are, say, 60, 70, 75, 45, 51, 55, 64, 67, 77, okay, 78, 89. Take these elements, form your B tree, and just tell me what is the structure of the tree. You make it, tell me, I will draw here. Do it now. So if it is done, you can unmute yourself and tell me that it's done, and I will draw the tree as per your instruction. Or otherwise, take this one as assignment. We will solve the deletions of different elements over this tree. Either you complete now, or we will continue the deletion process tomorrow. I'm waiting for your response.
Can we take it as an assignment and show you on the next day?
Yes, that you can do, because I understand it's also the last class. You are also doing the classes since morning. Then you can leave, and tomorrow we can start from here, and then we may discuss the deletions. Because if bit related problem comes, other than this, what is the restriction, maximum, minimum number of children and all, the partial tree can be given, then insertion or deletions need to be performed, and the final something has to be mentioned. So we need to know each and we have to prepare with each and everything. Okay, so you can take it as assignment, and for today you may leave the class. But those who are present, at least study. Otherwise, because even today I am asking very preliminary questions and the answers are not exactly perfect. This is very alarming situations. Very alarming. Also, your placement seasons will start maybe in next 10 days. We are getting maybe, and already you are getting different opportunities. So please study, please. And you can leave if you are not want to do it now, you can leave. Okay, so I'm ending this and we'll start from